Today what we're going to look at is something called standard form. And this is section 6.4 in your textbook if you're keeping track. So I'd like you to write these example problems down on your graph paper. You might want some notebook paper to go along with it. Standard form is just a way to write an equation of a line. It's different than the one we've already done, which was slope-intercept form, y equals mx plus b. So this is just a different way to do it. The general form is ax plus by equals c, where a, b, and c are constants, they're numbers. And then when you write your equation, you'll just have the x and the y there. So here's an example of one of the problems that actually has some numbers in it. Number 1, 3y minus 2x equals 6. So this is standard form because x and y are both on the left-hand side of the equation together instead of y being solved for. Now you can be thinking, how am I going to graph something like this? And you can always make a table if you're not sure. There is a method that makes it a little bit easier to do. And it's graphing using intercepts, meaning we're going to figure out where it crosses the x-axis and where it crosses the y-axis. Well, when it crosses the x-axis, then the y value has to be 0. So what I'm going to do is I'm going to work through this problem and I'm going to put a 0 in place of the y. Now notice when I put a 0 in place of the y, that whole thing is going to just become 0. And I'm left with a negative 2x equals 6. And if you divide by negative 2 on both sides, you get x equals to negative 3. So just to recap, I put a 0 in for my y, and I got a negative 3 out for my x. So I'm going to plot that point, and you'll find it on the x-axis out at negative 3. Now what I'm going to do is I'm going to figure out where it crosses the y-axis. So to figure out where it crosses the y-axis, I'm going to put a 0 in place of the x. So starting over, I have 3y minus 2 times 0, and that equals 6. Now again, hopefully you recognize that the 2 times 0 is just going to be 0. It's going to go away. So I'm left with 3y equals 6, and I'll divide by 3 on both sides, and y comes out to be 2. So if I write this as an ordered pair, x comes first and y, like always. Y was 2, and x is 0. So I'm going to plot that point 0, 2. So we've graphed this using intercepts because we figured out where it crossed the x and the y axis. I like to call this the cover-up game. So I know you can't see me right now, but what I'd be doing is I'd be looking at the problem, and whatever part that I'm going to plug a 0 in for, I'd be covering that up with my pencil or my hand, and then I'd just be solving for whatever variable is left. It's just a one-step process. Let's try out some more problems. Here's number 2. Let's graph 2x plus 3y equals 12. So again, my goal here is to figure out where it crosses the x and the y-axis. So this time, let's start with x, and let's figure out where it crosses the x-axis at. And so I'm going to put a 0 in for y. So I'm going to rewrite the problem, but this time I'm going to substitute that 0 value in there. Now again, when you put that 0 in place of the y, it simplifies away, and you end up with 2x equal to 12. I'm going to divide by 2 on both sides, and x equals 6. So to write this as an ordered pair, x, y, the x value is 6, and remember we put a 0 in place of the y. So I'll come out here, and I'll plot that point. Now we can rework the problem and figure out where it crosses the y-axis, so I'm going to put a 0 in place of the x. So start over, 2 times 0 plus 3y equals 12. 2 times 0 just simplifies out to 0, and I'm left with 3y equals 12, and I'll divide by 3 on both sides. Y equals 4. So if I write it as an ordered pair, this is x and this is y. The y value is 4 and the x value is 0. Now I have a point on each of my axes, and so I'm going to connect those to form my line. Let's try out another one. Here's number 3. 5x plus 2y equals negative 10. Again, my goal here is to figure out where it crosses the x-axis and where it crosses the y-axis. So maybe I want to start by solving for x. So I'm going to plug a 0 in place of the y. So be thinking about what that looks like. We're going to have an x here. 5x plus 2 times 0 equals a negative 10. This is going to simplify to 0, so we don't really need to write it. And I have 5x equals a negative 10. Divide by 5 on both sides. And x equals a negative 2. So the x value is negative 2, and remember we put a 0 in for y. So at x is negative 2, I'll have a point. Now I'm just going to flip it around, and I'll put a 0 in place of the x. The 0 times 5 is going to cancel out, and I'm left with 2y equals a negative 10. Divide by 2 on both sides, y equals a negative 5. So we put a 0 in place of the x, and we found that y was negative 5. Then you can connect those and form your line. Let's look at one more problem like this. We're going to add some negatives in there, make it kind of interesting. This is number 4. Let's say I had negative 3x minus 5y equals 15, and I wanted to graph this. So decide which one you want to put a 0 in for. It doesn't really matter. Maybe I'll put it in for x. So I have a negative 3 times 0 minus 5y equals 15. Again, this just simplifies away, and I'm going to end up with negative 5y equals 15. Divide that negative 5 out, and y equals a negative 3. So my x value was 0, my y value is a negative 3. Now I'm going to run through it again, but I'm just going to switch where my 0 is at, so I'm going to put a 0 in place of the y. This is going to simplify away, and you end up with a negative 3x equals 15. Divide by negative 3. X equals a negative 5. And we put a 0 in place of the y. I'm going to connect those to form my line. There is one more topic that I'd like to look at, and looks like I've run out of some graph paper here, so give me a second, I'm going to go find some. Okay, so what I wanted to look at, and we've already kind of discussed this a little bit, but I wanted to look at some special cases of lines. So one of them could be considered something like y equals 6. And how do you graph that? And a lot of students get really confused about that. So if you think about the point where on the y-axis where 6 is, and you put a point there, 1, 2, 3, 4, 5, 6, you end up right here. And that ordered pair is 0, 6. Now, the 0 represents the x value, and the y value is 6. So think of other places where the y value is 6, like 1, 6. The y value is 6. And I could put a point there. Or I could say 2, 6. And I could have put a point there. So hopefully you're seeing that this is going to be a line that has a slope of 0 and it's a horizontal line across. And one way that you can remember this, at least how I remember if I'm lost, is I think about taking that Y and flipping it upside down. And what letter of the alphabet does it kind of look like? Well, it kind of looks like an H for a horizontal line. That being said, we could also look at a case of x equals just a number, like x equals 5. So on the x-axis, you can go out to where 5 is located. And think about that particular point as 5, 0. So the x value is 5 and the y value is 0. Think about other ordered pairs that would have a 5 first. Well, you could have lots of different possibilities here. Maybe I want to put a -3 in there. So I go out to 5 and down to -3. Or maybe I choose 5, 4. So I'll go out to 5 and up to 4. And so hopefully you can see that this is a case of a vertical line. The slope here is considered undefined. And how I remember this is if you were to take that x and think about that letter and cut it in half, it's going to look like a V, so it's a vertical line. So those are some clues for you as you're trying to figure out those special cases. And that concludes the video on standard form.